Students, in this video, we will discuss about the use of Mollier chart. So, as you can see, this is a Mollier chart. So, I'm zooming in to show you what are the properties that we can go through and find using the Mollier chart. So, as we can see, this vertical line shows the enthalpy, specific enthalpy. So from here we can read the value of specific enthalpy. It is on the left and right both. Then on the top and on the bottom we have the specific entropy. So from here we can read the specific entropy. Then inside the chart, this dome shape represents the saturation line. Saturation line means where the dryness fraction is equal to 1. Now, the rest of the lines parallel to the slope, these are constant dryness fraction lines. It is mentioned over here, and the dryness fractions can be read as 0.95, 0.9, 0.85, 0.8 and so on till 0.7, right? 0.65 is also there. This is 0.7 only. So now these are the pressure lines, constant pressure lines. These one. It is might be written also. So these are constant pressure lines as it is mentioned here. Fine. So as we can read it from here, it will be 0.01, 0.02, 0.04, 0.05 and so on up to 80 bar, 100 bar it is there. Fine. Now what else? These lines are constant temperature lines. It is mentioned over here, and this is the temperature mentioned over above the line. So this is 150, 200, 250, 300. Now these lines, dotted lines, are constant specific volume lines. So as we can read it from here, it is 0.3, 0.5, 0.2 and so on. So this is the constant specific volume lines. So these are the properties which we can read from the Mollier chart. Now I'll tell you how to read the property using the Mollier chart. So for that, let us take a point. As we know that this is the saturation line, so above this line the condition will be superheated and below this line the condition will be saturated. So below this line it will be wet, on the line will be saturated condition. So let us take a point. We will take any point in a region. So I am taking this point. The cursor is at this point, and at this point we have to read the parameters enthalpy, entropy and the dryness fraction. So for this what we will do is we will see the enthalpy from the horizontal matching point on this vertical enthalpy line. So if this was the point, then we will move straight and we will see the enthalpy from here. Fine. And going back, if this is the point, then what else can be read? For the entropy, it will be this one. Fine. So entropy can be read from the basically what is done in the Mollier chart is we will take the this physical chart and then we will use a 12-inch scale so that this point can be marked using a pencil, and then a 12-inch scale will be used to draw the we will not basically physically draw the line, but we can move towards the straight horizontal or straight vertical axis or the slant axes to see the values. So now to find the dryness fraction, what we have to do is, as we know, if we want to find the dryness fraction at the same point, if the point is this one, then what we'll do will be, this is 0.95, 0.96, 0.97, 0.98, 0.99. So we are dividing the region from here to here into equal divisions as per the lines mentioned. So if we need to find the dryness fraction at a certain point, like I have taken a point where I have used this cursor. So for this, I'll read the dryness fraction as 0.95, 0.96, 0.97, and above 0.97, in the middle between the line of 0.97 and 0.98, it will be read as 0.975. If it will be towards the 0.98 line, then it will be 0.9875, 0.9775. Then this will be 0.9725. Similarly, this point will be 0.995, fine, in the middle. This will be 0.9975, this will be 0.9925, or it may be approximated to other regions also. If like it is here, then it will be 0.9915, fine. So like that we will approximate the things and we will have the dryness fraction. So this was for the wet region. Now I am moving on to the superheated region. So in the superheated region we will be here, and if we need to have the saturation, the super temperature of superheat at any point, then what we'll do will be, we will put, like I have this point. So this point is lying between the line of the temperature lines of 150 degrees Celsius and 200 degrees Celsius, and we can see that this is the middle of the two of these. So the temperature will be 175 degrees Celsius. It will be the temperature of superheat. Saturation temperature is on the saturation line, but this will be the temperature of superheat. Now, if the condition is like this, I have moved the cursor above, so the condition will be this, this will be 178 or 180 degree Celsius. Then over here it will be 190 degrees Celsius. So like this we can approximate the temperature of superheat. Now to have the specific volume, what we can do is, if this is the specific volume lines, the dotted lines are the specific volume lines. So this is 2.0 and this is 1.0, they are in meter cube per kg. So if the point is this, then it will be read as 1.5 meter cube per kg. If it will be this, it will be 1.25. If it will be this, it will be 1.75, and so on, and like this you can approximate the specific volume also. So we need to have all the data from the Mollier chart also when we are using the Mollier chart in the question, or it is mentioned in the question. So we cannot use the steam table in that case. Now, so these are the parameters. Now for some of the questions like turbines and nozzles, what we will do is, we will need the condition at inlet only, and then we can find the rest of the conditions. So for that, if I am taking a steam at 10 bar and 200 degrees Celsius. So let us see, the condition is superheated or dry or saturated. So this is 10 bar and this is 200 degrees Celsius. The two are meeting at this point, and this region is superheated region. So we can easily see that this will be the condition, and for reading the enthalpy we will move horizontally towards this, and we will read the enthalpy from the left vertical axis, and for the entropy we will move straight to the vertical axis, and then we can read the enthalpy from entropy from here, fine. So now what else we can read from the here is the specific volume. So this was 10 and this was 200. Specific volume can be read between this and this line, fine. So it is directly on the point. This is not visible here, but you can see whatever this volume is, the point is directly falling on this line only, fine. So this one, Fine, it is directly intersecting. Whatever value will be will be of the specific volume is this of this dotted line, that will be the value of the specific volume. Then in the questions, if it is given then that the condition is the pressure is dropping from here 10 bar to a pressure of 2 bar. Fine, let us take it as 5 bar. So we will move straight downward because the processes in the nozzle and turbine are the isentropic processes. So we will move straight downward to the pressure of 5 bar. So 5 bar line is this. So the condition at the exit will be found to be this one, and we can read the values of dryness fraction, enthalpy, entropy, specific volume from this point directly. We don't need to calculate the as much we needed to calculate in case of the use of steam tables. So the question duration will be reduced by uh, 10 minutes to 2 minutes. Fine. So from the left we can see the enthalpy, from downward we can see the entropy. For the dryness fraction, as we can see that this is the line of 0.99 dryness fraction, this is 1. So at this point it will be 0.996. Fine, and you can approximate it at your own end. Then specific volume can also be read. Now if you know the procedure for one, then you can find the value for any of these. Fine. So thank you so much. This was all about the Mollier chart, and now you can use this also for solving the question on nozzles, which will be very much easier and takes short time when you'll use the Mollier chart. Thank you so much.